everyone, Mrs. Below here. In this video, I'm going to be going over how to calculate molar mass. Now, just to clarify, molar mass says you have a certain amount of grams per 1 mole. It can also, another way to say the same thing is you have a certain amount of grams is equal to 1 mole. And that is unique for every element on the periodic table, or compound or molecule, depending on what you're putting together. So, for example, carbon. Here is a picture of carbon. So this is what it looks like in its purest form, this like blackish looking rock, basically coal. So if you had in your hand a lump of carbon that looked like this, and you had like that little carbon, and let's say you had 12.011 grams of that. You can also say that in your hand you have 1 mole of carbon, because on the periodic table, carbon 12.011, that's its molar mass. And as we learned previously, it's also its atomic weight, which is the average of all of its isotopes. So it's pretty cool what our periodic table can tell us. So we can use that information to calculate how many moles or grams we have of a specific element or of a specific compound or molecule. And later we're going to see how we can use that information to calculate, well then, how many molecules or atoms of that substance do you have? So let's start with water. So water is H2O on the periodic table. So what you would want to do first is you would find the molar mass of hydrogen, because that's the first element. So you're going to need the molar mass of all the elements listed in that compound. So we said earlier, if you just had carbon, it'd be 12.011. That would be its molar mass. Now we're going to look at molecules or compounds, so things that have multiple elements or multiple of the same element. So hydrogen is 1.008. And you'll notice that that hydrogen has a 2 subscript. It is H2. So that means you have 2 hydrogens present. So what we're going to do is we're going to multiply that number by 2. Its molar mass by 2, because we have 2 hydrogens. Plus, so you always want to add all of the elements together, okay? So you're going to multiply them by their subscripts, if they have any. And then you're going to add each of those elements, their molar masses, up separately. Next, we have oxygen. Now, we just have 1 oxygen. It doesn't have a subscript. And oxygen is 15.999. 15.999. And since it doesn't have a subscript, it doesn't have a number here, I don't have to multiply it by anything. And now we do the math. So just be careful of order of operations. So I'm going to do my multiplication first. So 1.008 times 2 equals, and then I'm going to add my oxygen. And I'm just going to write this answer using 4 significant figures. So 18.0. We're going to round that 1 up to a 2. And remember, the proper units for molar mass are grams per mole. So if you had 18.02 grams of water, which is actually the same as saying, if you remember from the density unit, chapter 2, if you had 18.02 grams of water, that's the same as 18.02 milliliters of water. So if you measured out exactly 18.02 milliliters of water, you would have exactly 1 mole of water. All right, let's do another example. So now we have Cl2. So chlorine is Cl because it's a C with a lowercase l. on the periodic table is 35.45. So that's the first thing you want to do is find your elements. 35.45. You want to find your elements on the periodic table and find out what their molar masses are. Now there's just chlorine present, so there's no other elements. And again, it has that 2 as a subscript. So I'm going to have to multiply this by 2. So 35.45 times 2. So that's 70.9. If I wanted to make this 4 sig figs, I would add another 0. And then the proper units again are grams per mole. All right, so what happens when we have something that is much more complex? So we have FeOH, and then there's a 2 in the parentheses there. So again, you're going to just work left to right. So first I see iron, which is Fe, and I only see one of those. There's no subscript with it. So I'm going to find Fe on the periodic table. It is right here, 55.845. And we don't have to multiply by anything because it does not have a subscript. Now we're going to move on to our other 2 elements that are in these parentheses here. So I'm going to explain what that is. So when you have something that is around parentheses, that means, so this is the same thing as saying you have 2 OHs. That subscript gets applied to the entire thing, so the entire thing that you have in there. So this is the same thing as saying this. You have 2 OHs. So that can help you with determining what you need to multiply by. So you can look at it like this, or you can look at it as like distributing. So that 2 is going to be multiplied, that's the subscript, right, by how much of each of those you have. And I have another example where there's where you do have subscripts here on these guys. That's in the homework. So my first element that I have is oxygen. And earlier we said that was 15.999. So I'm going to write that down first. And it looks like we have 2 oxygens, okay? So you can look at it as there's 2 oxygens here. You can also look at it as 2 times the 1 oxygen that's in the parentheses. 2 times 1 is 2. Next, we have the hydrogen. Hydrogen, we said earlier, is 1.008. Okay. And in this case, we have 2 hydrogens. So we have 1 here and 1 here. Or you can look at it as 2 times 1, which is 2. So we're also going to multiply that by 2. So we'll start with our multiplication first. That's where I like to start. So 15.999 times 2 plus, remember, use your parentheses, order of operations, plus 55.845. So 89.8, we're going to round that up to a 6. So 89.86. So I have 4 significant figures, and then your final units are grams per mole. All right, now I'm going to go over some problems in the homework. All right, let's pick a difficult one. All right, so let's go with number 3 here, just to explain it a little bit. So the aluminum here, you would multiply the molar mass of aluminum by 2. That would be your first part. Plus, and then you have the S and the O, so you have sulfur and oxygen. So this right here, this is the same thing as saying you have 3 SO3s. Okay? So you can look at it like that. Okay? So in total, you would have 3 of the sulfurs, but you would have a total of 3, 6, 9 oxygen. So you would have to do whatever the molar mass of sulfur is times 3, plus whatever the molar mass of oxygen is times 9, plus the molar mass of aluminum times 2. So you can draw it out like this if that helps. Or you can also look at it like this. 3 times 1. So 3 times 1 is 3. So if you have 3 of the sulfurs, which is the S, or you can also look at it as 3, there's a 3 here, 3 times 3, which is 9 oxygen. Okay, so that's a really important thing that you want to remember if you see that subscript on the outside here. Again, you can write it out like this. Okay, I have 3 of these, and figure out how many of each you have of those individual elements. Or you can distribute like this. And then lastly, I just want to mention for this problem, if you have 2 individual elements with no subscripts, you would just add their molar masses together. You don't have to multiply them by anything because they don't have any subscripts.